Hello, hello, hello. Welcome, everyone. It started in about 3 minutes. Hope everyone is having an excellent Wednesday today. Hey, welcome, Chris. And hi, Rascal, Early Bird Squad. As always, how's my audio? Do I sound okay? Good levels, everything? Awesome. Thanks, Chris. We have got a very interesting, thanks, Rascal. We've got a very interesting project tonight. It has been a while since I have done something kind of, out of left field and off the wall. And it seems like, some days you just want to make a spinny cube. So that's what we're going to be doing. Welcome in, everybody. We're going to get started in about 1 minute. Good to see everybody here. Hey, Inadequate. How's your Wednesday? Hey, Twisted. Hey, KT, welcome. Hey, Ohami, welcome. Good to see you. We're gonna get started here very soon. Oh, good to hear it, Inadequate. Hey, Jake Burr. No, I'm not wearing pink. I'm wearing red, so I guess that works. Hey, Cassava, welcome. Anybody do anything fun today? All right, Aroni. It is 7 p.m. Eastern, so let's go ahead and get started. All right. Hello. Hello, hello, hello. So this is just a sneak peek on what we're going to be building tonight, which is All Hail the Cube. I'm pretty excited about it. Cube. I even made an overlay. Go me. I just wanted to do something, funky and fun tonight. So you get Cube. It's 1 a.m. over here. Oh my goodness. Wow. Working on making your database huge. That's so cool. Went over React and Mern with your tutor. Ooh, goodness. Ah, you finished 4 hours of my 6 hour CRUD tutorial? That's all. That's way to stick it out. I remember how tired I was at the end of that. Golly gee. That was a heck of a thing. Um, hey Zeno, welcome. Hey Hog. Yeah, so this is pretty cool. This tutorial I think is going to be really fun just because it's not I mean it's a little break from the the other stuff we've been doing and we're on a break, right? We deserve to be able to do something completely weird and off the wall occasionally. And I realized I hadn't done one of these off the wall type projects in a while, you know, just completely out of left field, totally weird. And I'm super tired today and we're on a break. So I was like, man, I just want to make a spinning cube. And so we're going to make a spinning cube. Um, and we're not gonna do this like ad hoc either. We're gonna follow a tutorial. So you'll have the tutorial. You know, the code is out there on GitHub. This isn't in kind of like a homework assignment or anything like that. Um, yeah, we're just gonna kind of work through the tutorial together and, you know, have fun and maybe sometimes struggle through it, but we'll get it. And I think this is kind of a cool demonstration of what the internet is, or what the web is capable of. The fact that we can, you know, do this type of rendering directly in our browser with it, just there's no, the cool thing about this is it's built in WebGL. And so this cube is running in the browser. There's no plugins, you know, nothing. I mean, it's just running in the browser, which I think is really cool. And also too, with Microsoft retiring Internet Explorer officially, getting rid of that stalwart of your middle school classroom, I figured we ought to maybe take a little blast to the past and build a Windows 95 style screensaver like Spinny Q here. So I don't know if y'all remember the Windows 95 screensaver that like squished and morphed, and you know, the cube that like, you know, colored cube just like this that was like squishy. Yeah, that was a pretty fun one. The memories come flooding back seeing this. Yeah, absolutely. So now we're gonna do, you know, in a couple hours what it took, you know, Windows 95 devs probably, you know, way longer to do with the magic of the browser and JavaScript. So cool. Um, hey, Aparica, welcome. Nothing like procrastinating on code by working on other code. Yeah. uh, Oh, thanks, Andrea. Yeah, no, I am tired, but it's mostly my own doing. I was up late last night working on a work project, but not because I had to, not because like my employer was telling me you have to work on this project. It was more like I can't let this go. And so I was up way too late last night, and it turns out I wouldn't have figured it out anyway. I had to have a meeting with like three other people in the dev team today, and then we finally figured it out. But I would not have been able to figure it out myself, no matter how long I worked on it. So that's, you know, that'll teach me for just trying to, you know, bash my head against the wall until I got it, because I wouldn't have solved it anyway. So sometimes you just need a team. Oh my goodness, thank you so much for the raid. I love the spinny emoji. It's perfect. Oh, hey Tame. Yeah, so we're gonna be making this with WebGL today. We're gonna dip our toes in a little bit of WebGL and make a spinny cube. Yeah, a computer indeed. Why watch the Banky VOD when you can make a spinny cube? Yeah, I like the way you think. All right, so unfortunately, Spinny Cube is. I'm gonna have to pan away from Spinny Cube for a moment to give you some of the things, to give you some links to the things that we're gonna be working on tonight. So say bye to Spinny Cube for now. We'll see Spinny Cube again. Um, Did you have a good stream, Vero? Good to see you. Thank you so much for the raid. Yeah, so we are going to be using the WebGL API, and by Spinny Cube, yeah. I'm going to post a link to it in the chat here, so you're welcome to have this open and code along, or just watch. It's all good. Tonight, it's like whatever, man. We're just chilling. All right, so here's a link to this MDN tutorial for using WebGL. And also here is a direct link to the actual like example that we're going to be coding up to. There's multiple examples in this tutorial. We're not going to do the whole thing because I physically think we would not have time. So we're going to go up to the multicolored spinny cube part, and then maybe if you want to, you can go farther. But this is where the code ends in the tutorial. So that we're going to try to get to tonight. So there's that. That's the GitHub code. So feel free to grab that. or, you know, just code along as we go. So I think we're going to have a lot of fun tonight. And let's take a look at kind of what we're working with here. So I love the sadness for Spinny Cube being gone. It is interesting. So, you know, like I said, this is rendering, like this is, you know, hardware rendering that's rendering the cube. And so when I had Spinny Cube up on the screen, I could like I could hear my tower fan going, you know, because it's like, you know, it's sweating a little bit, like doing the rendering, which is weird because it's, you know, it's a pretty powerful graphics card, but it is interesting. But I'm not sure that it's able to, I'm not sure if it's able to use the graphics card or if it has to do it, you know, if it's browser rendering, if it has to do it, you know, just like CPU rendering. But that's an interesting question. But yeah, I could hear it like when Spinny Cube was up, I could hear my fan going. Anyway, so what are we doing here? So we're using, I'm using WebGL, which is, as it says here, 2D and 3D graphics for the web. And it is an API. So some of you may have been around long enough on my streams to remember when previously we used Canvas to do some fun things. I think at the past screensaver that we did, which was bouncy balls, I believe we used Canvas for that, and that was a 2D animation. And so Canvas, you know, is an API as well that can be used to, you know, draw things and animate things in the browser. And this is basically like Canvas, you know, 2.0. This allows you to do 3D rendering in the browser as well. Thanks, Xmetrics. Thank you for the context there. Yeah. So if the browser is configured to GPU acceleration, it should use it. Yeah, that makes sense. Yeah. WebGL can use the GPU. Yeah, that makes sense. Okay, so WebGL is an API like Canvas was, except it allows us to be 3D as well as 2D. And there's, you know, like MDN likes to do, there's a lot of wordiness here, right? But really it's just saying like, you know, look, we can use the HTML5 Canvas elements like we've used in the past to do some pretty wild stuff. And yeah, and it says down here, the Canvas element is also used by the Canvas API to do 2D graphics on web pages, which is what we've used before. Hey, Intelligence, welcome. Good to see you. Okay, so let's go ahead and get started. And so what we're going to do is just kind of follow along with the steps of the tutorial, and we're going to be doing steps 1, 2, 3, 4, and 5. And it does say it's assumed that you already have an understanding of the mathematics involved in 3D graphics, which we do not. But that's okay. We're going to roll with it. Sometimes, you know, it's fun to just kind of like dive into something without really understanding it and seeing what you get at the end. So that's what we're going to do. Yeah, Snarfin. So I mean, you probably would want to, you know, study up a little bit on this Canvas API specifically, because I think the WebGL stuff is going to be a little bit wild, you know, as far as like what it's using. Canvas itself is a little bit more straightforward. Yeah. Hey, Digital, welcome. Oh, thank you. Yeah, so Digital, like this isn't the project we're doing tonight isn't related to any sort of homework assignment or anything like that. But if you look at a lot of my past streams, you can see a lot of my past VODs on my Twitch channel, and many of those are related to specifically to class topics. And you can also check out my YouTube channel as well, !YouTube in the chat, if you want a link to my YouTube channel where you'll see even more of my videos. So good to see you. Thanks for joining. No math gang, yeah. All right. So, and we've got the code examples. And there's more, you know, applications that can use WebGL as well, such as Three.js and Babylon.js. Okay, so let's go ahead and we'll prep our canvas. So I'm going to see if I can get these things to fit properly on my screen. Arranging windows, yeah. All right, we'll go ahead and set up our, and we don't need anything special here. We're just going to get, you know, have an index.html. We're going to have our main.js and our style.css. Okay. No worries, Xmetrics. Okay, so let's set up our basic, index.html. So in order to do that, we can just type, let's see, I'm not in CSS, sorry. We can just type HTML5, and that'll give us our basic structure for our HTML file. And it's telling us to prepare to render in 3D. The first thing we need to do is to embed an HTML fragment here into our body. So we'll go ahead and copy that. And what this is going to do is it's going to set up our canvas, which you may or may not remember from my previous canvas tutorial. Is like, yeah, this is basically setting up the area in which these canvas elements can work, in which we can animate and render things. Yeah. Oh, Vera, so you went through some Mongo docs, excuse me, and going more down the rabbit hole. Ooh. Well, good to see you. Always good to see you. Okay, so we've got our canvas here, and we can change the size of our canvas. I'm actually going to make it a little bit bigger than this, because on my screen it'll be teensy. So we're going to go ahead and make it like, I don't know. We'll just do like 1,000 by, and we can always resize it too. I don't know, 1,000 by 750. So that's really all we need to do for the HTML there. And so the main function in our JavaScript code is called when our script is loaded. Its purpose is to set up the Webgl context and start rendering our content. Okay, so let's set that up as well. And we'll go over to our main.js. All right, so we have a main function. And first we're going to set up our canvas variable. Again, this might be familiar if you've used canvas before. Use basically, and and basically what we're going to be doing is we're going to be, just using canvas, and then like methods that are associated with canvas and methods that are associated with WebGL. So this should be pretty familiar with how we've applied this sort of thing before. Document query selector, GL canvas. All right. And so, first we could basically kind of need to just initialize these things. Const GL canvas dot get context. Now, if you, in our previous tutorial, we used not WebGL, but I think it might give us, okay, so it's going to give us a list here of the different contexts that we can have. It's a little bit cut off there. But I think previously what we've used is 2D. But it says basically, hey, you're telling the browser, what type of canvas are you creating? So Internet Explorer 9 and Internet Explorer 10, RIP, they only supported 2D context, whereas Internet Explorer 11 supports 3D or WebGL context. Yeah. So basically we're saying, all right, what are you going to be rendering in here? And we're going to be rendering WebGL. Okay. And then the next thing is really just a check to make sure that WebGL is actually running. Okay, so if GL is null, basically saying, hey, were we able to initialize WebGL or not? So I'm just going to copy and paste this alert because I don't want to type it. So unable to initialize WebGL. So pretty straightforward stuff so far, right? Cool. And then we're also going to set the color of our background canvas to be black, because in the spirit of a good, Windows 95 screensaver, the background is going to be black. So what was everybody's favorite Windows 95 screensaver? I think we might have talked about this before, but I am curious. What's everybody's favorite Windows 95 screensaver? Or I'll accept Windows XP as well, really, if or Windows 98. I'm lenient. What was everybody's favorite screensaver? Oh, thank you for the hydrate. Ah, the maze, the pipes. The pipes are sticks. Yeah. Oh, a 3D text because you could customize it. Yeah. Oh, Stefan, that's a good one, Stefan. Fishes. That was a really fun one. 3D text, 3D maze, flying. Oh, throwback. Windows 3.1. Oh, nice. And the next thing we're going to do is we're going to set up our clearing our color buffer. Color buffer bit. Okay. And I have too many brackets. Get rid of that. And that. Okay. And basically then we're saying whenever we load the window on load. On load, I can't spell either. Basically just start the canvas when we start this main function, draw the canvas when we load the window. Yeah. Your box that had Windows 3.1 spent most of its time in DOS games. Oh man, yeah, there was a bunch of crazy downloadable screensavers as well, right? Yeah, my favorite. So yeah, my favorite was definitely the maze. I think I said in a previous stream, like as a kid, I was easily entertained, and I would just like sit in front of the maze and just watch it because what I really wanted to see was, like occasionally you would go like the maze would flip or that you would see like a rat in the maze, and I would just sit and wait for that to happen. So again, easily amused child. Um, Okay, window unload main. All right, so that's our first function here. Basically just initializing our canvas. So the first thing we did here is obtain a reference to the canvas and assign it to a variable named canvas. So then we're passing in, like I said before, we're saying get context and telling it that we're going to be using Webgl. And so our variable GL is now our reference to any element associated with Webgl. And so now we should have a nice big black empty box. So let's see if that worked. Oh, and I should probably save things, you know. Oh, and I didn't link any of my scripts either. Oof. All right. Let me do that real quick. In my HTML, I need to link my scripts. So I'm just grab script source main.js, and we're going to put it down here. Actually, I'm going to break the rules a little bit, and I'm going to put it up top because I'm using defer here, and so this is what the example uses, which it says basically the script is meant to be executed after the document has been parsed. So rather than putting it at the end, I'm going to be putting it at the top with this defer keyword here, just as kind of a little experiment here. So I'm going to save that main.js, and I'm also going to link my style sheet as well. And all right, so link style sheet. It's called style.css. Okay, and I'm gonna call this web. Oh no, I'm just gonna call this cube. All right, there we go. Okay. Now let's see. Once I save everything, now let's see if it works. Yay! It's a blank canvas. Cool. Ah. Wow, isn't this impressive? Go us. We're so good. All right. At least we got that right. Okay, following. Let's miss some stuff in the chat here. How long did it take for me to get comfortable coding? I don't think anybody's ever really, comfort is an interesting question, is an interesting thing, right? Doing this tutorial, like with WebGL, I don't know nothing about 3D animation or WebGL, but I'm doing it anyway. I think, and that's kind of how I've done things most of the time. I learned how to code on the job. For those, I mean, I'm sure everybody's heard this a million times by now, but I don't have a CS degree, and I kind of just stumbled into coding by getting a job that required coding. So I have always been kind of little fish, big pond in my coding career. And so I've never really been truly comfortable just because I always feel like I'm being pushed to the edge of my abilities, but that's a good thing. You always want to feel like you're a little bit out of your comfort zone because that's how you learn stuff. If you're like, oh gosh, I don't know what's going on, I have to work really hard and learn this and figure it out and get on top of it, then that's what gives you that pressure to learn. At least in my case, I don't feel like I get, I don't feel like I ever stagnate because I'm always like, wait, what's going on? Which is why I like this course, because it moves super fast. And so we're just like, you gotta be on top of it. Yeah. Getting nostalgic in here. Defer is one of the best things. Yeah, it seems pretty cool. And like, I haven't used it before, Xmetric. So that's why I wanted to try it here. I think it's, rather than putting your script at the end, just put it at the start and say defer. I think that's kind of neat. How many countless lifetimes have collective humanity wasted because defer didn't exist? Congratulations, a black screen of death. Indeed, we're so good. All all that monitor toner wasted. Yeah. Ah, man. Who's gonna pay for the ink now? But I'm smooth with it. Yeah. And that's, that's a learned skill too, is learning to project confidence or project an adaptability, even if you're like, oh God, what's happening? And that's learned. You just pick, you just start to pick that up after a while. So don't worry. Also try streaming. Streaming really helps people learn. Yes, it does. By streaming, that's how I learn most of the stuff that happens in class. All right, so this was, we've already finished example 1. We're so good. Now, example 2. So this is the second chapter or whatever. This one is the longest and probably has the least satisfying result, but it sets us up for the cool stuff that's coming later. Okay. So just bear with me through this one, and then after this one, we set up all of our scaffolding, we set up our foundation, and we get to do fun stuff in the last like 3 chapters after this. So power through, and then we will start adding colors and spinny bits in 3D. So. You don't remember the last time you've seen a screensaver? They always have screensavers running. Yes, they do. And someday, have an old Windows XP machine somewhere. Yeah. So, interesting side note, a lot of ATMs run OS Warp, which was like an offshoot operating system that had a big run for a while and then like fizzled out. But a lot of ATMs apparently still run like OS Warp, which I thought was wild. I think I saw a meme the other day with the DVD logo floating around. Yeah, that would be fun to animate. That's funny, Steve. There's Stefan, yeah. You've just applied for an internal junior .NET dev job that has come up despite very little C#. Like very little C# job. So averagely, are you saying you applied for that even though you don't really have a lot of knowledge in that in C#? Well, that's awesome. Yeah, I mean, I applied for a SQL position like few years ago when I was first starting out, just like a year out of college, and that's how I got started on my career as a dev. Is just like sort of bull crapping my way through the through the first couple months, and then picking it up on the fly as I went because I really didn't have the skill set that they were exactly looking for. So, hey Jim, welcome. All right, so let's go ahead and start drawing our scene. Okay. So we've successfully created our WebGL context, remember, which is like our canvas, our rendering area. And so we're going to start rendering stuff in it. So we're going to draw a simple square untextured plane. Doesn't that sound exciting? Let's draw a square, everybody. We're going to start there by building our code to draw a square plane. Cool. But like I say, we're going to be setting up the foundation for a lot of the stuff we're going to be doing later. Now, note, this project uses the GL matrix library to perform matrix operations, so we will need to include that in our project. We're loading a copy from the CDN in our HTML's head. So let's all do that real quick. I'm going to paste in chat exactly what you need, and then you're going to watch me do it as well. So I'm going to give you exactly the tags that you need. I'm going to drop it in chat for you. And grab this and put it in your HTML. And I'm going to put it in my HTML as well. So I'm gonna grab it, my notes. Boop. And I'm going to, and you can put it in your HTML up top in the head, just below the link to your style sheet. So between the link to your style sheet and the link to your main.js. So just drop that bad boy in there. And basically what this is doing is it's just linking to this external library that we'll need to do some calculation stuff, math. I don't know. Yeah. So drop that in there. Otherwise your stuff won't work, and then save it. Okay. And again, you can see this in their GitHub. So if you go to the GitHub link, you can also copy it from there if you would like to, if the chat link isn't working for any reason. So just copy the whole thing, the script tags and everything, and drop it in your HTML. All right, cool. I'm going to assume y'all did that. So Kel, managing frustration is like a constant struggle when you're a dev, and so it's important to have some strategies. And a lot of folks are saying Pomodoro, and that is great. Yeah, because knowing when to stop, to take a break, is really hard sometimes. You just want to like I did last night. Like, that was stupid. I worked for hours on something that I wasn't going to be able to solve anyway, and all I got for it today was being tired. And so what I really should have been doing is taking breaks, reevaluating, saying, okay, should I just go to bed? And so, yes, that was a mistake last night, as I should have been doing, taking regular breaks and taking care of myself. But I didn't. So here we are. And you built some apps in C# averagely? That's rad. Yeah, I hope you get it averagely. That's so cool. That's a great opportunity. Hey, Sirius, welcome. Xmetric, you had a killer idea for a Twitch extension. Okay. That's cool. Awesome. I'm glad I'm glad you had your inspiration on my stream. I will take 5% of whatever you make. No, I'm kidding. 5% commission, please. No, I don't need your money. Okay, so we've added in our source for our matrix library. Now let's see if we can draw our scene. So the most important thing to understand before we get started is that even though we're only rendering a square plane object, in this example, we're still drawing in 3D space. It's just that we're drawing a square and we're putting it directly in front of the camera, perpendicular to the view direction. We need to define the shaders that will create the color for our simple scene, as well as draw our object. This will establish how the square plane appears on the screen. So you can think of it as like in a movie, how they might use so you might see an actor in front of a white background, but if you were to step around the camera, you would see it's just a flat sheet that's just facing the camera, right? So it's just a flat square that's facing the camera. And so that's what you need to think about it as, like, we are the screen is like the camera facing a 3D object. Tried to follow a tutorial today and I typed something that made the entire app disappear and I couldn't figure it out. 3 months ago me would have stormed away, but I took a deep breath and recalled what I learned. Hey, that's awesome. Try again tomorrow. Yeah, absolutely. Yep. And there are times when I get so freaking frustrated, you just like, why won't you work? And but the important thing is to know that there is a solution, and sometimes it's a little harder to solve than others. For example, the issue that I was having last night and part of today ended up having to have like 3 other team members come in and be on a call with me, and we were all working on it together, and literally everything was correct. It was how the program was interpreting a number, and it had like some sort of like floating point error out to like the 100th decimal that you couldn't even see. And so it was treating it as like non-duplicate. It was the wildest thing, and nobody could figure it out. And so in the end, we were just like, yeah, I'm just going to make that into a string. Not even going to treat it like a number. It's going to be a string. And then it worked. It's the weirdest thing. So yeah, frustration is inevitable no matter how far along you are in your career. So it's good that you're figuring out ways to manage it. Clip that bit of mind. Frustration is a state of being for me. Yeah, it's perpetual, right? Okay, so we're going to draw our scene, and it's a 2D object in a 3D space. So a shader is a program, and it's written using a shading language that takes information about the vertices that make up a shape and generate the data needed to render the pixel on the screen, namely the position of the pixels and their colors. Okay, let's pause for 1 second and let's look up the word vertices, all right? What's a vertex? All right, so the definition is the highest point, the top or apex, or in geometry, it's each angular point of a polygon, polyhedron, or other figure. Okay, so and there's a little image here. So vertex is, so if we're looking at like this pyramid here, the vertexes are the points, right? So in a 3D object, in this context, that's what we're talking about when we say, because you're going to see the word vertex a lot. So I really want everybody to be aware of what that is. It's the pointy bits, all right? It's the pointy bits. So we're going to see that word a lot. So as long as everybody's aware of what that is, we can all work together on this. So, all right. So there are two shader functions that run, the vertex shader and the fragment shader. Okay, fair enough. Together, a set of vertex and fragment shaders is called a shader program. Okay. Do it in VB. I've done some VBA in my time. All right, so each time a shape is rendered, the vertex shader is run for each vertex in the shape. Okay. So, and it transforms it into a coordinate system used by WebGL, which access has a range from -1 to 1. Okay, fair enough, regardless of aspect ratio or size or anything else. So it's doing a bunch of math, and it is saving it in a special variable called GL position. Okay. And it can also do things like determine the coordinates within the face's texture of the pixel to apply to the vertex, apply the normals to apply the lighting factor, and so on. So vertex shaders are very powerful. They can do a lot of things. All right, I'll accept that. We don't have to know all this stuff. It's just really just introducing us to some terms. So don't worry about digesting all this. We're just going to kind of just slap it in there and see what we get. Okay? Vertex. Ah, no! IRL word ban. Dervas, you're killing me. All right. Cool. We'll work with it. All right, clock starts now. 7:34. 5-minute word ban on that word. Vert. I'm going to say vert. You get that. I can't go without saying it completely. So we get vert. All right. 7:40 comes back. 1,000 points for every time I mess up. Okay. So let's just copy this and we'll just drop it in. We don't have to worry about what all this is doing. It's basically just setting up all the math stuff. Math stuff. Yeah. All right. Okay, so we're going to have this const vSource. And I'm going to put this, let's see, I'm just trying to look at the best place to... we'll just put it at, we'll put it after, so we'll just put it right after our first function for now. We might end up moving that, but yeah, we'll put it there for now. Okay. And so apparently there's different attributes that you can use. We're going to use vec4. Good to know. And we're not doing any lighting effects at all. There is an example later where we can do some lighting effects if you really want to. That's down here. So lighting in WebGL. So later on, if you want to play with that, you absolutely can. We're probably not going to get that far tonight, knowing how slow I go and how long my streams generally take. And we're also not doing any textures, but again, you can. There's a step for that later on. Okay, so the fragment shader is called once for every pixel on each shape to be drawn. After the verts have been processed by the vert shader, its job is to determine the color of that pixel by figuring out which texel, that is the pixel from within the shape's texture, to apply to the pixel. Okay, so the fragment shader looks to see sort of which vert it belongs to, and then says, all right, now which texture do I need to apply to literally each pixel in our shape, which I think is pretty cool. So it gets that texel's color and then applies the appropriate lighting to the color. The color is then returned to the WebGL layer, and it's stored in this GL frag color variable. Color is then drawn to the screen in the correct position for the corresponding pixel. In this case, we're returning white every time because we are drawing a white square. All right, let's do it. Draw that square. All right. So we're going to go ahead and put it below our VS source, FS source, okay? And we got our 1111, and we're just rendering white every single time. Hey, Aiko, welcome. Tonight we're building a spinny cube. You can't really see it because it's out of the window, but yes, this is what we're building tonight. Hey, Aiko, I'm very new to WebGL, so we're just following a tutorial tonight. But we are building something fun, which is spinny cube. Okay. So now let's initialize our shaders. So, okay, we need to pass them to WebGL, compile them, and link them together. So we're going to call load shader, pass the type and source, and links them together and compile them so they're ready to shade stuff. All right. Here, make sure get things in the right order, but we'll just go down here below, and if it's in the wrong order, it won't be a big deal. Okay, so we're going to say init shader program, and we're bringing in some of the parameters that we set up earlier, our GL, our VS source, and our FS source. So all the things that we set up previously, we're going to bring those into this as parameters, and we're going to set up we're going to set up our vertex shader and our fragment shader. Vertex shader and load shader. Also too, like I say, this is going to be like a chill stream tonight. So if you have questions about stuff, we've had some good questions already tonight. Just questions about like anything. I don't care. We're on a break. Feel free to ask. I'm happy to answer. Okay, so got everything there. We're loading our shader for our vertex, and then we're also going to, I'm just going to copy this, and we're going to need to load our fragment shader as well. Fragment shader. And for this, we're loading fragment. Oh, and I spelled shader wrong, not once, but twice. Go me. Good job. Fragment shader and FS source. Okay. Yeah, it'll be easier with 3JS. Native WebGL is very hard. Yeah, so they actually, you know, advertise that at the start of the tutorials that there are ways to make this easier. I think what we do is, you know, what we generally do in 100 devs is we start with the harder way of looking at it, so we understand the concepts, and then we apply, you know, add like layers on top that, you know, can help make things easier for us, like starting with Node and then adding Express on top, right? Yeah. Darth shader. Yeah. Hey Jim. Yeah, so there was a hydrate a little while back, but I'm gonna hydrate again. Oh, and I can say vertex again. Haha. I think I said it a couple times before the time ran out, but nobody said anything, so I'm going to take it as a win. All right. So we've initialized these constants. Now we can start our shader program. Okay. So constant shader program. What's wild is that we, you know, we're going to do all this wild stuff and then actually like just to draw a square. We're gonna do all this wild stuff just to draw a square and then wait until we get to the next step, or wait until we get to the step where we actually make it 3D and animated, and it's like, you know, just a few lines. It's like, what? How is 3D so easy when drawing a square is so hard? All right, create program. and attach our shaders to it. Shader, program, and we're going to grab our vertex shader and do another one. Shader program and fragment shader. And link program. And also too, for those of you who are new, we generally take breaks on the hour, so we'll be taking a break in about 15 minutes. Link program, shader program. Oops. Okay. That is a very large mug. Ah, Karses, you are new to my mug game. I have 2 of these mugs, and this one has a naughty word on it, so I keep it turned away from the camera, but I should make that a channel point reward. Yes. My other mug is a NASA mug, but they're both gigantic, and I love them. They're from my former employer, which was an e-commerce store, or e-commerce online store. So I got all of their like discarded products. So like anything that the customer didn't want, I would literally just be like, "Yes, I want this," and you know, it was a little perk. It was one of those that job's very few perks was getting all the random junk that I wanted. Okay. The last thing we're going to do is just a little check to make sure if the shaders did not initialize, we are going to know about it. So we're just going to say if this program didn't initialize, get program parameter shader program and get the link status. Okay, and then, oh, and I have an extra parenthesis there, sorry. Yep, link status, and just say alert. Again, I'm not going to type that out. I'm going to copy and paste it from the tutorial. There. Okay. And so what all this is doing is basically just setting up the shader program and returning it when the function is called. So remember that the return keyword, essentially when a function is, you know, called, it's gonna do a bunch of stuff and then return the end result upward. And so, you know, in most cases we would assign that result to like a variable or something like that, but in this case it might be used differently. It would be cool to have kittens on the rotating cube. Yeah, well, like I say, there's a texture tutorial just a little bit later on. So using textures in WebGL. So if you want to, you could make a kitten cube. Yeah. Texture loading isn't much of a step from the final result, at least a single texture. Yeah, raw WebGL is still tough. Yeah, it is. But hey, that's why we're doing it, right? Better download a kitten 3D object and load that in. An animated one, yeah, like Bonzi Buddy or one of those. You know, remember like the web assistant. Remember the web assistants from like Windows XP. Like there was the little cat and the little dog. That was like the upgrade from Clippy. Yeah, remember like because you know there was Clippy right in Word. Yeah, exactly. Clippy. Yeah. And then we got with Windows XP, we got the far superior upgrade of the cute little puppy that sat in your search box. I still miss that little dog. It helped me find things in my files. Yeah. Okay, so return shader program. So now we're going to create a shader of the given type and compile it. Okay. We can do that. Right. Function load shader and pass in GL type and source. Const shader and create a shader. Old friends, Clippy is back. What the heck? Source, shader, and source. And then compile. And then check if it compiled. Okay, so this was similar to the previous check. So I'm going to copy and paste this just because I don't want to type all this stuff in the alert box. But basically we're just saying, all right, check and see if the shader compiled correctly, and if it didn't, please alert and get any log info on the error, and then return null. So and then if it did work, we just return the shader. And so, you know, this is an example of basically taking all these different actions that are, you know, sort of related to each other, collapsing them into functions, right? Like putting them in functions of buckets so that we can call them and return only what we need and when we need it. So this is a great example of, you know, using functions for that purpose, which is, you know, kind of what we've talked about a lot, right? Sort of getting back to how we structure code. Libby.js exists. Of course it does. Not surprised in the slightest. Okay, so here, what happened there? So the load shader function took the Webgl context, the shader type, and the source code, and then created and compiled the shader. So we created a new shader calling create shader, sent the source code to the shader, and then compiled it. And then we checked to see if it worked. Okay, fair enough. And then we can call it by saying const shader program equals init shader program. Yeah, just like we would call, you know, any other function, right? And because we're using a return there, so that means the results of that function will be assigned to the shader program variable. Okay. And so in the GitHub code, the that call, this const shader program call, is actually right after the fsource function. So wherever that is, fsource, right here, yeah. So the function is called right after const fsource is declared. So I'm going to go ahead and put it up there, const shader program. Because they don't really say where to put it, so kind of going off of what they have on their GitHub. GL, DS source, and FS source. Yeah, which makes sense where that is, because, you know, we've got our FS source declared, VS source declared, and then down below we created the shader program and pop that right in there. So perfect. Okay. And after we have, oh, check shadertoy.com, amazing examples of what you can do. Oh, awesome. Yeah, definitely check that out. Okay, so after we've created our shader program, we need to look up the locations where WebGL assigned to our inputs. So I don't know what attributes or uniforms are, but that's all right. We'll roll with it. Attributes receive values from buffers, but okay, uniforms are similar to JavaScript global variables. Fair enough. They stay the same value for all iterations of a shader. Okay, so we're setting some global variables as uniforms, and since the attribute and uniform locations are specific to a single shader program, we'll store them together to make them easy to pass around, okay? So I'm going to put this up here underneath, right underneath where we call the shader program. I'm going to pop this right up here, and we're going to say const program info, and kind of basically just set up some uniform or global variable type stuff. And basically, you know, basically we're creating an object, right? This is what we're gonna be creating an object with keys and properties, right? We know what this is. We've been doing this a lot lately. Program is gonna be shader program. attrib locations is going to be vertex position. So we've got a nested object here. Which, out of curiosity, when you all are building out your MongoDBs, has anybody done like nested objects inside of your MongoDB? I'm just curious. Because, all the stuff we've done on stream has been flat objects, just single level objects. But I'm curious, has anybody messed around with nesting in Mongo? Well, position. Yeah. Okay. Also, I'm gonna get it up. Let's make it a little. There we go. You have Xmetric. Okay. Has anybody else tried any nested like database entries for your APIs? Oh, you've been learning SQL, and all the data relations get you dizzy. Yeah, yeah. So, SQL and NoSQL databases have very different, interpretations of like relationships and that kind of thing. It's really interesting to think about. It's like being a SQL dev, it really doesn't prepare you necessarily for, I mean, it does a little bit, right? Like knowing how, generally how to query for things, but the relationships are very different between SQL and NoSQL databases. So it's interesting. Get array and nested object. Okay, yeah, that's rad. You've nested episode numbers inside of an episode array. Yeah. Still feels like writing SQL with differing objects having relation. Yeah. Yeah, sometimes like, man, if you're trying to, when you're trying to nest stuff, it's like, man, this feels like it might be easier if I could just have like an episode table with like, thinking like a relational database, having an episode table and having like, a season table and that sort of thing and linking them together that way. But that's just because I'm more familiar with SQL. So yeah. Okay. And so we have our vertex position, we have our attrib locations. And next we have uniform locations. So for that, we have a projection matrix. GL get uniform location. And in that, we'll have our shader program and a U projection matrix, whatever that is. Okay. And then the last thing is our model view matrix. And again, the important thing is to know, not to know everything that's going on here, but to be willing to try, right? Throw stuff at the wall, like my philosophy. Throw stuff at the wall, see what you get. So U model view matrix. And, okay. And and I'm missing a comma. Boop. There we go. Okay, so what do we have here is we have an object essentially with top level keys and then some nested keys and properties as well, which I think is cool. Yeah, some people think more relational. The idea is keys makes more sense, but then they get into things like foreign keys and they're like, what? Yeah. Yeah, and I think relationally, just because I have like a few years of being a SQL dev under my belt now, and that's all I've ever known. So, really keeping an open mind and not saying that NoSQL or SQL databases one is better than the other. I see some folks, like, we've just now gotten into Mongo, and some folks are already like, yeah, Mongo is way better, or no, SQL is way better. And I don't think that's the right approach. I don't think that's the right way to look at it. I think the right way to look at it is there's, different tools for different jobs, right? Sometimes a relational database is going to be better if you have a really flat, relational type data set. But if you have a more like messy, chaotic type data, I really think that, that's not something you can necessarily contain inside of a relational database. And so sometimes, object-oriented databases, NoSQL databases are much better for that kind of thing. So it's just finding the right tool for the job, right? And in order to do that, you have to know which tool is the right tool. You have to know about them. My line 42 has 2 U's. Oh, thank you. There we go. Yeah, that's a good point, Dean Bull. If you know how your data is going to look and it's huge, then SQL is good. Yes. If you're not too sure how your data is going to look, then yeah, Mongo is great for if you're not quite sure how your data is going to be structured. Yep. Yeah, X matrices, and we're going to see how matrices look here in a minute. We're just not quite there yet, but we will definitely. Okay, so we've got our setting up our global stuff. Now let's create our. So finally, after all this buildup, we finally get to draw a square, everybody. Yay! Let's draw a square. All right, but before we do that, we need to create the buffer that contains the vertex conditions and put the vertex positions and put the vertex positions into it. Okay, so we'll do this, then we'll take a break, and then we'll come back, and we might get the chance to draw a square. We'll do that using a function we call init buffers. As we explore more advanced WebGL concepts, this routine will be augmented to create more complex 3D objects. Okay, fair enough. So buffers. So I'm just trying to keep code in the right. We'll just do it. I'll do it right here. Okay. All right, so we're going to initialize some buffers. And declare a variable. Create buffer. Right. And we're going to bind our buffer. I just like saying the word buffer, it's fun. That and concatenate. Buffer and concatenate, those are good words. Not biffer. Position buffer, okay. Sounds like you're squared away. Hey. Nice. That was it. I like that you waited and like just, threw that one out there at the perfect time. That was good, Ryan. Okay, so we've bound our buffer. And now we get to kind of see like, yeah, what Xmetrics was talking about. We start to set up some positioning, some matrices. So const positions, and let's see, get this stuff positioned decently. A little far apart, but -1.0, and that's not very even, but whatever. 1.0 and 1.0. Math. 1.0. I should be using spaces, but I'm too lazy for that. .o. I have to use spaces all the time in PL SQL instead of tabs. Okay. So there's our position matrix, and we're going to pass the list of positions into Web. So essentially, what we're doing is we're telling WebGL where to start where to render those vertices, right? So we're just like, hey, where do you want? Where do we want these vertices to go in order to render our shape? Yeah. So using math, we can tell it things. So now we're going to pass those positions into WebGL to build our shape. All right, so GL buffer data. Array buffer. And we're setting up a float array. Float 32 array with our positions in it. And then finally, we get to draw something. So GL static draw. Yay, drawing. Okay. Float 32 array positions, GL static draw, and then finally, we return the results of that. There we go. Okay. This routine is pretty simplistic. Debatable. Given the basic nature of the scene in this example, so we store our vertex positions inside of a buffer, and then we bind it to the context, and then we create an array containing the position for each vertex of the square plane. Remember, so vertexes are the corners, right? They're the pointy bits. And so for each vertex of the square, you can see there's 4 of them here. So, 4 vertices. We convert it to an array of floats and then establish the vertex position for the object. Okay, so the last thing we're going to do is we're actually going to render it, and so it displays on the screen. But before we do that, we're going to take a break, and if anybody's still here, but y'all haven't dropped off by now. But hopefully at least some of you come back after the break when we draw our glorious square. And then after that, we will start adding some color, and then animate our 2D square so it spins, and then we're going to turn it into a 3D square and then make that square spin. So that's the progression of what we're going to do. I'm going to bring back spinny square, and I'm going to pull up a timer for 5 minutes, and I will see you all back here very shortly. Zoom in a little bit. Set that. All right. Hey, Brooke, welcome. Spinny square. Indeed. Enjoy the spinny square for 5 minutes, and I'll see y'all back here in a minute. Okay, folks, come on back, come on back. We got about a minute left. See you all back here shortly. Alrighty, I need just a few more seconds to get my dog squared away, and I'll be right back, okay? Okay, and we're back. Sorry for the little extra wait there. And that was my dog choking on some kibble there in the background. Don't know if you could hear that. But yeah, he's having a he's on the struggle bus today. So yeah. All right. We are back and in business. Let's draw a square. Extra weight equals extra spinning cube time. Yes, absolutely. Never a bad thing. Okay, so rendering the scene. So now we actually, we have the ability to draw our square. Now we're actually going to render it. So once the shaders are established, we did that. Once the locations are looked up and the vertex positions are put in a buffer, so it knows where it's going to be drawing the square, we can actually render the scene. So we're not animating anything in here, so we're going to draw just a static square. Okay. So let's draw our scene. Here. Scene. Just taking a quick look to see where to put it. Okay, that's fine. We'll put it all the way down here. Yeah, it'll be fine. Doesn't really matter anyway exactly where it is, but okay. Function draw scene. And we're going to pass in our GL, our program info, and our buffers. Okay, so the first thing we're going to do before we start to draw is we're going to clear the canvas, right? We want to make sure that we have a nice blank canvas to start drawing on. And so we're going to set our canvas to black. And also too, so if you all, remember anything about CSS at all, there's so you can sometimes draw in colors with an opacity. You can have like RGB and then opacity. And so that's what we're doing here. We're saying, all right, draw all black, 0, 0, 0, and then 1.0, so fully opaque. And clear everything. And enable depth testing. Okay, that sounds cool. Let's do that. Depth test. That sounds like a bad 80s action movie. Depth test. And depth function. Okay, I get this. So depth function. So depth, like when you're thinking about from a 3D perspective, right? Depth is, foreground, background, right? And so in this case, we're saying near things obscure far things, right? So Oh, and I forgot there was a stretch that was redeemed over the break. So stretch real quick. Thank you for that. There was a couple of stretches that were redeemed. So you get the neck crack too. Oof, heard that one. Okay. Near things, obscure far things. Cool, got it. And so we've set our clear color, and now we actually want to clear the canvas itself. Clear our color buffer that we set up earlier, clear that. Color buffer bit. And our depth as well. Whoops, that's a pipe, that's not F/. I keep spelling buffer as biffer. Hey Isaac, welcome. Today we're building a spinny cube. It's gonna be rad. But right now we're drawing a square. Okay, so we're gonna create a perspective matrix. Ooh. It simulates the distortion of perspective in a camera. Our field of view is 45 degrees with a width-height ratio that matches the display size of the canvas, and we only want to see objects between 0.1 units and 100 units away from the camera. Since we're just drawing a square, this isn't a big deal right now. But later on, when we're actually rendering something in 3D, we want to, know, okay, how far away from the camera are we supposed to see things? What angle are we looking at things at? And that kind of thing. So we set up our field of view. Nobody can tell us our square isn't a cube just from a straight on angle. Exactly. I like the way you think. Tomato, tomato, biffer, buffer. Indeed. Well, it's like, have you ever seen those art projects that people do where they like make a simple shape out of like a whole pile of objects? I just think that's so cool. So that's what I choose to believe this is. All right, so we got our 45-degree angle, and then we're literally saying, all right, math me. Let's do some math. And we set our radians. So it's the field of view in radians. I remember radians. I remember that I always used to accidentally set my calculator to radians when you're trying to do like a calc exam, and then you get in trouble because all your calculations would be wrong, which definitely hasn't happened to me. Math and me did not get along, surprisingly. All right, so setting our aspect ratio and just saying like, yep, our space of vision is just our canvas width and canvas height. Canvas, client height, and spell height. There we go. And our distance. Did anybody else? Line 58. Oh. Ooh, good catch. What did I do there? Supposed to be GL. Oh, yeah, thank you. Good catch. Like that y'all are looking out for me. It's good stuff. If this doesn't work, we can always just, compare it against the GitHub code and see where I screwed up, which is entirely possible. All right, so we're setting our field of view and we're setting our projection matrix. At 4.create. And then we essentially are just passing in all the perspective information that we set up. We just pass all that in together. So we pass in our projection matrix and our field of view, our aspects, our z near, and our z far. Okay. And then we need to tell it where to start drawing. So in general, we want that to be in the center of the screen, right? So const model view matrix equals mat4 create. Okay. Hey, Flo. Unfortunately, so you know, in 100 devs, we aren't learning this type of thing, but this is a fun little side project. But most of the time, you know, on my streams, I do stick to like homework. But right now, the 100 devs course is on a break for a couple weeks, and so we're doing some wacky side projects. Yeah. Okay, so we're gonna translate this down just a little bit. This is just moving things down just a teensy little bit. And we're translating it downward. I think that's down. I don't know for sure. Moving it somewhere, a little bit. We'll see how, when it renders, we'll see if it we'll see which direction it moved it down a little bit. Or which direction it moved it. 0 and translating it there. Okay. Tell Webgl how to pull out the positions from the position buffer into the vertex position attribute. Okay, I have no idea what that's saying, but let's do it anyway. All right. Oh, it's pulling. Okay, so it's pulling out of the buffer. Okay, so we made the buffer earlier, and now we're pulling values out of it. All right, fair enough. Num components equals 2. And we're telling it, oops, not that. Saying, hey, this is a bunch of floats. Don't normalize. That's my life philosophy. Never normalize. Don't normalize yourself. Be weird. I'm glad we're telling our program to do that as well. Const stride equals 0. Stride. That's interesting. I have 0 stride when I'm laying on the couch playing video games. And const offset. Leon the boss man, Leon the baller, indeed. We should make a cube with like the Leon logo on every side of it. That would be awesome. Somebody should do that. One of you all better do that. One of you all better make a spinny cube. So like just go a little bit farther. Go to the using textures. So we're gonna get as far as this chapter right here. Go to this one, figure out how to do it, and make a Leon spinny cube and tag him on Twitter. Just tag me too so I can see it. bl.bind buffer. And last thing is our attribute pointer and our attribute array. Okay. Lots of things in it. Thank goodness for VS Code autocomplete. Attribute locations. Remember, this is from the object that we sent up earlier, so we can use dot notation to drill down into that object. Type, normalize, stride, offset, and parentheses. Okay. And last thing is GX enable. Enable our attribute array and program info. Okay, whew, that was a lot. We're almost done though. We almost got it. We're almost good enough to draw a square. All right, now we tell it what program to use. program. Set up some, set up our global variables. Uniform matrix for FB. Projection matrix, false. Okay. And projection matrix. Right. Copy that. Oh, so it's just program it. So we've got the projection matrix and the model view matrix. Okay, so I'm going to copy and paste that. And I'm going to change this to model view matrix. And model view matrix. All right. Last thing, and then we'll actually, once we finish typing this out, we'll actually see what it's doing, because I have no idea. Okay, and then our vertex count is 4. Triangle strip. Huh. Offset and vertex count. Okay. Whew. Nelly. All right, what did we do here? The first step, we cleared our canvas to the background color. We established the camera's perspective with a field of view of 45 degrees and set the width and height to match the display dimensions of the canvas. Hey, Leah, welcome. We established the position of our square by loading the identity and translating away from the camera by 6 units. Okay, and we tell Webgl how to pull data out of our shader buffer. And then finally, we draw the object. Okay. Let's go ahead and save this and see if it actually did anything. All right. Wait. So this is that's the finished project. Oh. So I have a white box. That's something. So it should be a black canvas with a white square like this. So, wonder where I screwed up. Well, same here, yeah. Hey, Genpo. Well, luckily, we do have the finished code. So what I'm going to do is just take a quick peek. First try! Yeah. So let's take a quick peek and we'll look at sample 2. And we're not going to, we're not going to beat ourselves up about this. We're just going to take a quick look and see where we might have gone wrong. All right. So we've got our GL canvas, Webgl. And we've got our GL initializer. Oh, let's look in the, just look in the console real quick. If there's, there's an error. Okay. GL is not defined at main.js 45. Okay. GL matrix reference. Yeah, I mean, I did link it in, and like, obviously, I mean, it does work. Well, we can, it can use it definitely because the finished project does work. So let's see, what does it do? What does not it like? Come on. Be larger. All right, there we go. Okay, so it doesn't like when we're passing it into the init shader program. Oh, what's the GitHub for the code? Yeah, this is the GitHub for the code that we've done so far, and then you can just click up further if you want to see it. Like to see the other examples, you can go up to the root. shader program, init shader program GL source. Okay, well let's look at how they did it. Maybe we misinterpreted something, and that's fine too. Okay, void main, concept source, void main, frag color. Looks fine so far. Const shader program, init shader program. Okay, so that looks the same as ours. Well, GL is defined, is it out of scope? So yeah, it's interesting. They define it inside this main function here. So maybe, so const GL is actually declared within this main function, and then they call main. I wonder, okay, hang on. Where is main called? Oh, main is called at the start versus I think I have it called in the wrong place. So let's try this. I'm gonna grab, where is main? Window onload main. Where is main? What did I do with it? Oh, I think maybe I'm not calling it at all. That would be a problem. Let's do this. I'm just gonna check something real quick. Sorry for the fast scroll. Yeah, I don't think I should have to. Let's just try something here. Whoop. Ooh, sorry. Here, I'm gonna take this and get rid of that because they don't have that. And I'm just gonna call main. I'm just gonna play around a little bit with scope here. I'm just gonna do it like they did it here. Hey, look at that. So we're closer. We've got the canvas now. So the canvas is back. So that's good. That's better. So we're getting there. Sometimes your errors you got to iterate, through your errors before you can get to the right place. So, okay. Oh, okay. So yeah, it looks like, but no, I think you're right, Xmetrics. So the closing bracket for this main function actually is not, where does that even end? Yeah, okay. You're right, Xmetrics. Yeah. So it actually ends after draw scene. So the main function doesn't end here. It actually ends after draw scene. Okay, so now we got to make sure we got things in the right order. All right, so we've got main. Got the check to see whether it's valid. We've got our VS source. All those things. We've got our FS source. We've got our shader program. We've got the program info. And then we call init buffers. I don't remember it saying that, but that's fine. Init buffers, we'll go ahead and call that with GL. And then we will actually draw the scene. I may have that farther down. Let's see. Yeah, I'm not calling it. It didn't ever have us call. Actually, it didn't ever actually have us call those functions that we made, like draw scene. It's that faded color because we never called it. So bad tutorial, bad. That's all right. That's why we have GitHub. Draw scene and pass in those things. Unless I missed it, that's very possible as well. I'm very tired. Program info. And buffers. Okay, here we go. And then after that, we can actually close our main function. There. Okay, and then after that, see, const buffers, init buffers, draw scene. Okay, and then after that, we have these additional functions here. Yeah. You'll create buffer and all that. Just checking this. It looks right. Because the reason that our square didn't show up is because we never called the functions that we wrote to make it happen. So got the field of view and all those things, map for create, components, attribute array, offset, triangle strip, initializing the shader program, loading the shader program, and returning the shader. Okay, so that looks better now. Let's save this and see what happens. Hey, we got a square. Whoa! Ow. Y'all, we drew a square. I'm very proud of us. Yeah, Xmetric, actually, I was thinking that you know, we built those functions and then the tutorial actually never told us to call them, right? It never said like, you know, actually call our draw function. So, yes. It's a universe just from one angle, exactly. Woo, came with a celebration. Yeah, well, Xmetric, I did have so I had my closing bracket. So my problem was I had my closing bracket in the wrong place. So it wasn't, so GL was out of scope, like everybody was saying, which you're absolutely right. And also, but it never, so I was missing these two things right here. I was missing the buffers where it actually called that init buffers. So I didn't have that at all. So it would never, regardless of the onload thing, it would never have initialized that function. Oops. And then also I didn't have it calling draw scene either. So it wouldn't have drawn anything because I was never calling it. So the onload thing didn't really, it wouldn't have mattered anyway. Yeah, so now we've drawn a square and we've also set up a lot of the scaffolding that we need for future. So this is the grunt work and we've done a lot of that. So now we can actually start adding some color and animating our square to make it spinny before we move it into the third dimension and make it spinny cube. All right, so that was by far the longest section, but we did it. Good for us. And again, if you're not getting it, just go to this. This is the code that we just painstakingly typed out. It's all there, and so if you want to follow along going forward, you can start there. And is this 3J? Nope. We're just doing raw Webgl for now because we're hardcore. All right, so we did section 2. Now we get to apply some color to our shaders. Okay, so we created a square plane in our previous demonstration. And so we're gonna add a splash of color to it. We're gonna do that. We're gonna add a lot of fun, like a fun rainbow pattern. Happy Pride Month, by the way. So yes, we're gonna add like rainbow splashes to it. Okay, in WebGL, objects are built using sets of vertices. Remember, vertices are the pointy bits on a shape, each of which has a position and a color. So all other pixels' colors are computed using interpolation, creating smooth gradients. Okay. Before, our vertex shader did not apply any specific colors to the vertices, and we just use white on all the pixels. But now we're going to add color to our pixels. Let's say we want to render a gradient in which each corner of the square is a different color: red, blue, green, and white. So we establish the colors for the vertices, and then they'll kind of bleed into each other in the middle. So we create an array of colors and then store it into a buffer. So we're going to go to our init buffers function, which is down here. And function init buffers, we've got all this stuff. And buffer, I'm just trying to make sure I get it in the right place. Return, okay, so it's gonna go right here. So we've got our positions and position buffer, so, and color buffer. So I'm assuming that I need to leave this alone, but we'll see. All right, so we're gonna set up some colors. And we're gonna assign them as red, white, red, green, and blue. Okay. And I don't really want to type all this out, so I'm going to copy and paste this part. Okay, white, red, green, and blue. And then we're going to basically make a buffer to store those colors in. Color buffer. create buffer. And then just like before, we create it, we bind it. And we put those colors inside of a float 32 array, just like before. Set up a new array and put our color array into it. Cool. Static draw. Okay. And then in the end, we want to return the position buffer and our color buffer now. Okay, so the code starts by creating a JavaScript array containing four value vectors, one for each vertex color. And a Webgl buffer is allocated to store the colors, and the array is converted into floats and stored in the buffer. Okay, so we need to also update our VS source, which is at the top of our code. Const VS source. So we have vertex position, which we've already done, but now we're adding in attribute vec4 vertex color. Vec4 a vertex color. Okay. And then we also need to say some other stuff about color. So varying low p, which I assume is low poly, but I don't know for sure. Vec4 b color. Okay. And then we leave the rest of it alone, and then we go into our GL position, and we need to add one more variable. B color equals a vertex color. Okay. And then we need to change our F source to look slightly different. So before we just passed in a color of white, right? Everything was white, but now we want a varying color set. So we're going to change it to be varying low p vec4 color. And void main, void. And our GL frag color is going to be changed from vec4, just solid white, to b color. Okay. Allow us to have pretty colors. Each fragment receives the interpolated color based on its position relative to the vertex positions instead of a fixed value. Okay, so yeah, so the closer it is to the vertex, the more like that vertex's color it's going to be, and as it goes farther into the square, it's going to sort of diffuse that color and be a lovely little gradient. And if anybody doesn't know, a gradient is when there's like a gradual color change over time. So like think about like word art, right? Y'all remember word art from like, I don't know, the early 2000s that was so popular on flyers and stuff. So a lot of those use color gradients, and they thought they looked so sweet and cool. But yeah, word art was a thing for a while. Okay, so now we need to add some code to look up the attribute location for the colors and setup. The attribute for the shader program. They thought they looked so sweet. Oh, okay, all right. I'm sorry. I didn't know that. I didn't know there was a fan base for word art out there, along with that clip art portion. Yeah, clip art was the jam. It was. Yes, many in elementary school and middle school and high school project relied heavily on clip art for success. Okay, so we need to add some code to look up the location for the colors and set up the attribute for the shader program. Okay, let's see, we already have our program info. So we've got our vertex positions, a vertex position. So we just need to add one more to this, right? To our object, and we just need to add one called vertex color. get attribute location and shader program, a vertex color. All right. And then the last thing we need to do is modify our draw function, the function that actually draws it, and give it the ability to use those colors. Draw scene. So we're going to go all the way down here to where we start declaring some variables, and we're going to change the number of components from 2 to 4. Our content type is still going to be GL float, normalize false, stride 0, offset 0, array buffer, buffers dot color. So that probably means I could have gotten rid of that position earlier. We'll double check that. We'll see if it runs, and then we may need to modify it a little bit. Program info, vertex color. Maybe it won't matter if we don't touch it. Num components, type, normalize, stride, and offset. Warning, this is derailing. Bad tutorial. Okay, I don't know what that means, but I mean, this is the MDN, so it surprises me a little bit, but which line is that, Snarfin? Which line did I mess up there? Void main, which, you know which line that was? Const fs source, okay. Oh, yep. Good catch. Yeah, that's why I love y'all. Okay. Oh, I see. Okay. So, were we supposed to, I wasn't supposed to replace these. I was supposed to copy and paste. Is that what you're telling me? X metrics. I can always look at the GitHub and see. Let's check that real quick. Because yeah, it's not entirely clear on that. Yeah, okay. So it was a copy paste. That's fine. So there's supposed to be 2 sections which are pretty much identical except for the number of components. It looks like it looked like it was trying to tell me to replace them, but I can see that it's not. So we can fix that. That's fine. Yes, tutorial doesn't specify that you need 2 of those objects. Instead of modifying the block of code, you add it so there's 2 chunks that look alike. Yeah, that makes sense. Okay, so if you're following along, there's 2 sections. So leave your position 1 in place. And so I'm just going to back up a little bit, but it's still going to correct that. I'll come back and correct that, but there we go. All right, so I'm going to leave this one alone. And after vertex position, I'm going to add a new one that essentially copies it. And yeah. And 2, what they've done, you can see what they've done here is they've actually enclosed them in brackets. Now, anybody know why I might do that? Why would I? Okay, first question, why am I getting underlines here? And then why did they use brackets here in their GitHub code? Anybody know? This is a fun question, kind of related to what we were talking about earlier with you know, why GL wasn't. You don't get to Rascal, you and Xmetric don't get to answer. I know you know. Yeah, it's because they're Satanists. Yeah, so let's see what happens if we add some brackets here. Oh, hello. What? Look at that. The little underlinees went away, right? So, and that's because of scope, right? Like we talked about before. Brackets sort of give us boundaries for where variables are valid and where they are not. And so if you add brackets, that's basically going to prevent these variables that are declared inside the brackets from being able to be used outside of the brackets, right? So yeah, and GL is outside of this scope, so it can still it can travel in, right? It can travel in to the brackets, but things that are declared inside the brackets cannot travel out. They can't go upward. They can go, like, if we declare a global variable, right? Like at the start of our code that's outside of any functions, it can be used in all functions. But in general, we like to be careful about scope and try to keep things self-contained inside of functions whenever we can. And so in this case, because they want to be able to use, essentially duplicate these variables, they put them inside brackets to fence them in a little bit. And so we'll set our components to 4, normalize false, array buffer, color buffer. Could we use a constructor here? Well, I mean, it depends. If we were building a lot of these, then that might not be a bad idea. But in this case, I think we're only going to be building 2. So I don't know that it would be worth the effort to build a constructor. But I mean, constructors are great when you want to duplicate, when you essentially want to, recreate things with a standard pattern, right? I'm going to make this look a little better. I'm just adding some extra spaces, or sorry, some extra carriage returns here. Go, just to make it look better. Okay. Vertex color, vertex position. All right, and the last thing I need to do is what Snarfin pointed out earlier. I made a typo up here, and I need to change this from voice to void. Good eye on that. Okay, now let's go back to the tutorial and see. All right, so that was the last thing. And got those. The last thing I want to check is I want to review my my draw. See, no, it wasn't draw scene. It was init buffers. I want to review this and see if I got this right. Init buffer, position buffer, const position, const colors. They have things in a different order. If that matters. We'll see. We'll try it and we'll see if it doesn't work. Whoops. See if it doesn't work, then. Ooh, void syntax error. Okay. An error occurred compiling the shader. So that's interesting. So our little error thing worked. Good. Hey, Sacred, welcome. Good to see ya. Oh, I'm glad you're enjoying the MongoDB using the DOM. Yeah, that was really fun. I had a lot of fun doing that one. I hope you enjoy. Yeah, I hope you enjoy that, and I hope it helps you hook up MongoDB to to flesh out your API a little bit faster. Okay, that's fine. Let's go and look and see where I screwed up. Gotta love troubleshooting. Troubleshooting is a major part of being a dev, so gotta have the patience for it, right? Champo, don't worry if you're struggling with this. This is a hard one, right? This is nothing like what we've covered ever. So this is just a fun little side diversion. So don't worry about it too much. But you can remember, you can always look at the GitHub like I'm doing and compare your code. So I think probably my mistake is here in init buffer. So let's look at it. I'm going to zoom in a little bit. Buffer, create buffer, find our buffer, define our positions. We know that worked from last time. All right, so I'm going to move my position array up a little bit. Maybe I don't have that. Did I overwrite it? I might have overwritten it accidentally. That'll do it. Oh, no, here it is. Float array positions, static draw. Okay, this. And we set up the colors, stuff, create buffer, static draw, return both. Well, Xmetric, we know that this tutorial does work because Spinny Cube is alive. So it's just we just got to power through it, and that's I knew this tutorial was going to be hard, but part of why I'm doing it is because troubleshooting is important. Oh, okay, I got you. Someone's making sure the version numbers all match. Yeah, yeah. Okay, so we got create buffer, do the static draw, and return that. Okay, I'm going to check my draw scene here. Depth buffer bit, got the field of view. We did that already. That's fine. Components. Okay. Oh, hang on. I figured, okay, there it is, right there. I didn't change that from position to color, and I didn't change it here either. There's a mistake. Ta-da. Okay, program info.program. Got the matrix. Got the projection matrix and the model view matrix. Vertex count is 4. Everything else is looking okay. Vertex and fragment shader. Right. And last thing is loading the shaders, which gave us our error. That's where our error came from. So we know that works. All right, let's save this again. Let's shave this again. Okay, so we still got a syntax error, error.file. Okay, let's look and see if, yeah, let's look in the Chrome console here. Okay, failed to execute attached shader on web rendering context. Parameter 2 is not of type WebGL shader. Okay. Main.js 180. All right, so init shader program. This is also an exercise in creative troubleshooting as well. All right, so init shader program. It'll attach shader. Okay. Here, right down here. All right. Vertex shader, fragment shader. Failed to execute attached shader on WebGL rendering. Okay. Parameter 2, which is vertex shader. Okay, so it doesn't like vertex shader, is what I declared up here. It's helpful to watch troubleshooting in action. Sometimes it's just a lot of I'm glad it's helpful anyway, because you're going to get to watch me do it here for a little bit. Okay, so VL source source shader program vertex shader. Parameter 2, which is vertex shader, is not a type of WebGL shader. Okay. So let's look at their init shader program. So they'll compare, see if I mistyped anything. Oh, wait. Nope, it's fine. Okay, never mind. False alarm. You get that a lot too. Fragment shader, FS source. Program. Thank you for the troubleshooting follow there, Catherine. Data program. Rascal. Yep, it's like draw the rest of the owl. Debugging can be the most important part, indeed. Thank you, graphics. I'm glad y'all enjoy troubleshooting so much. I should do this more often. This is the kind of thing. So this is the kind of thing that you don't normally see. Like most of my projects on stream, I have them down, right? Like I'm like, you know, I'm just rolling you through them. But a lot of what you don't see, a lot of what's behind the scenes is this, of just like staring at it until you see what's wrong. And because I really didn't do any preparation for tonight, this is what you see. So you get to see how the cookies are made a little bit. A lot of staring at things. Okay. Wonder if there's a problem in VS source. Double check VS source because it doesn't like the second. So it said it didn't like the second parameter in attached shader. Right, that was the error. I think if I reload this, we can. So okay, failed to execute attached shader on parameter 2 is not of type Webgl shader. Okay, so that means that there's something wrong with vertex shader, and vertex shader consists of load shader GL, so GL works. We know that. GL, vertex shader, and VS source. So there's something wrong there. Okay, so let's look back at those. So we'll start with VS source, which is up toward the top. Let's see what might have gone wrong there, because I did hand type a lot of that, so it's very possible that I made a spelling error, which has been known to happen. Y'all know how bad I spell. Not smell, but spell. All right, vec for a vertex position. Whoever catches the spelling error first gets a virtual cookie. Map for you projection matrix. Color. Whoa, Rascal, did you get it? Oh, we got a semicolon. Missing semicolon. Ah, Nelly. Okay, and we got another one here. Let's see. A lot of semicolons, yeah. I'm pretty sloppy with the semicolons. V color, A vertex color. Okay, let's put all these back. Yeah, we'll be tidy with our semicolons here. Void main. Oh, right here. Look at this. All right, and I missed a void there. Void main void. Yep, I got it down in the. So I got it down right in the FS source. We'll fix all of our semicolons. We'll be real neat and tidy about this. So I missed that void, which may do that as well. Yeah. And we'll save that. Let's see if we got any better. Whoa! We got a colorful cube. It's a cube with many colors. Yeah, so that was fun. That was a fun little exercise in troubleshooting. So how did we figure that out? Let's think about that for a second. How did we troubleshoot that? So we got an error, right? And so well, first thing, our program alerted us that something was wrong. We got an alert box. So I clicked OK on that, but then I used the console, right? We used the console to look at the error, and then we used the links in the console to click on the error to see exactly which line of our code it was on. And then we read the context of the error. So it wasn't the error was on that line. It was that it couldn't initialize, it got to that line and then it couldn't figure out where to go. Like it couldn't proceed any farther. So it flagged the error there. So it flagged the error there. And so we had to get, so I'm going to trigger the error again. Okay. And we'll do a quick rerun as to how we figured this out. Because I think it's important when you get a multi-step problem like this, when you get a multi-layer problem like this, to know how to solve it. So I'm going to put this back. All right. We'll reload it. Let's see if I can trigger the error again. Oh, it still works. No, wait. Let me get rid of some semicolons. We're going to see if we can break it. There we go. All right. Okay. So it gave us an error, right? Uh-oh, what do we do? Well, we can inspect, and we can see that the error has been thrown in the console. So we can go to the console, and it says, okay, so it gives us the same error that it did before. So failed to execute attached shader. And so the first thing we always want to do is just click in and have Google show you where your problem is. So in this case, we saw it was in attached shader. Well, that's all well and good, but if we look at the actual error text, it says it can't execute this. So it's not that this is wrong. It knows what it's trying to do here, but it says it can't execute that because parameter 2 is not a valid shader type. Okay, so we have to pay attention to what the error is actually telling us. And so in this case, we know that parameters are things that we pass into our function, right? So this is parameter 1, and this is parameter 2. Okay, so vertex shader. What was that? So then we had to track that back and say, all right, well, vertex shader is a variable that we declared right up here, right? Vertex shader. So we said load shader. Okay. GL, when we've used GL before, so we know that there's nothing wrong with that. And we have two things. We have vertex shader and VS source. And in this case, out of the two of those, the one that I figured would probably be the problem, and it ended up being the problem, was VS source. And why did I think that? Because VS source is one big string. And so we don't have any of the protections that VS Code normally gives us, telling us when things are wrong. Because inside of a string, it doesn't care what we type, right? VS Code doesn't care strings. It's like, yeah, type whatever you want. I don't care. And so in this case, VS source is a string. And so it's very easy to screw up. And I did. So that's when we said, all right, that's where the problem is. So we fixed our semicolons and I fixed the missing void. And so troubleshooting, effective troubleshooting is a really good skill to learn because you're going to have to do it a lot once you get your dev job. And when you get your first dev job, one of the things that you might be like asked to do is to troubleshoot code that's screwed up, you know, just, hey, fix this code, newbie, you know, that kind of thing. So, all right, let's see if I fixed it. Hey, color cube. All right. Commonly, what throws the error isn't the, yeah, then Rascal, that's a great way to put it. Commonly, what throws the error isn't where the actual error is located, just the first thing that couldn't keep moving forward. Exactly. Okay, so we're going to take a break now, but when we come back, we're going to turn our color cube into a spinny cube. We're going to make it spin, and this next section actually isn't all that long. Like once we actually get into the animation stuff, it's not bad because we set up all of our scaffolding already to make it work. So when we get back, we're going to have spinny square, and then the last thing we'll do is spinny cube. We'll turn it from a square into a cube. All right, so you get to watch spinny cube for a minute, and I'll pull up the timer. Pew, pew, pew. All right, get that going. Chanpo, no, that's fine. I mean, like you're not gonna you're not necessarily gonna get this like immediately, and you shouldn't. This is a really hard tutorial. We're doing it basically we're doing it because I wanted to make a spinny cube. And I know I've been hemorrhaging viewers since the start of this stream just because this tutorial is killer. And you're on a break, so you know, don't rack your brains too hard about it. I just want to make a cube spin, and I don't care how many people watch me do it. So, you know, if you have to, if you're not getting it, feel free to, you know, just go back to the GitHub and just scan down line by line and see. You probably got a spelling error somewhere, and that's, you know, I missed a bunch of semicolons and a void, so it's really easy to mess this one up. But when we get back, we'll make spinny square, and then we'll make spinny cube last thing. This is the stuff you need. Yeah, that's a great way to put it, Count the Shells. This is the stuff you need to get your hands dirty with, starting something new with zero experience and learning from there. Yep. That's how I like to learn. I like to take something and like know literally nothing about it, do it anyway without understanding it, and then you start to notice patterns and you start to see the things that, you know, like, oh, I recognize that. I've done that before. Or I've used that function before. Or, oh, I finally understand how these two things work together just by, you know, um, by experience, right? You know, you just by exposure, you expose yourself to it until you start to recognize patterns and how things, you start to see the bigger picture. So rather than just reading about it, I'm gonna make a spinny cube. Okay, we're gonna take our break. We got about 4 minutes left. I'm gonna sit down for a minute, and then I will see y'all back here in 4 minutes. And welcome, Max Kowalski. I saw a stream doing respectable hours. Good morning to you. Okay, folks, come on back. Oh yeah, Chris, thanks for asking. So for those of you who don't know, this weekend I actually stepped on a nail in my backyard. I have a lovely backyard, and unfortunately, there happened to be a nail in it. And I was walking around in bare feet, as I often do, and I stepped right on a nail, right in the the ball of my foot, like the right before the toes. And so yeah, that was something. Um, yes, the nail. Luckily, I mean, it didn't damage anything. It just hurt like crazy. And so yes, and luckily, I have had a tetanus shot in the last year, so I was prepared. Um, it, and I went to urgent care. I got antibiotics. It kind of went downhill for a little bit, so I went back to urgent care and I got an antibiotic shot in a slightly awkward location. And after that, it seems to have resolved itself very nicely. I did go to see a specialist this morning, and I think I spent like $300 to have somebody look at my foot for like 30 seconds and tell me everything was going to be fine. That's America for you. We pay a lot for healthcare. So yeah, but I think my foot's going to be okay. Long story short. Yes. Yep. So all good. Yeah. I do, but hey, I actually have really good insurance through my employer. That's why y'all should get a good job in tech so you can get excellent insurance. So actually, I probably won't be paying all that much. So yes, I do appreciate I have excellent benefits through my employer. So very happy with that. Okay, so we drew our colorful square. Whoop, that's not it. We drew our colorful square, as you can see here. So the next thing we're going to do is we're going to make it spin. Rotating square. Nope, I keep clicking the wrong thing. And also, I just got a raise at work too, so I'm pretty happy about that as well. It's that time of year. All right. We applied color and we're going to animate our objects. Okay, so the next thing we're going to do is we're going to make our square rotate. Cool beans. So we're going to need a new variable called square rotation. Yes, the raise should just about cover the cost of the cost of injuring my foot. I'm kidding, but only kind of. All right, so we're gonna have a new variable for square rotation. So in this is going to be a global variable, so we're actually going to just go ahead and declare it at the very top of our code. So we'll declare this and we'll just say let square rotation equals 0.0. All right, and now we're going to update our draw scene function to essentially, we're going to rotate. We're not going to rotate the square, but this is what I think is interesting. We're not going to rotate our square. We're going to rotate the camera when drawing the square. So we're rotating the camera instead of the square itself. Yeah. Okay, so draw scene down here, and we're going to add a translate. So we have our initial translate here, and I'm going to make this a little easier to read. Different lines here. So we got mode view matrix. There we go. So this is our initial translation, and we're going to add a rotation underneath it. Match 4.rotate. And do model view matrix. And model view matrix again, and the square rotation. And the next thing is the axis to rotate around, and we would just want to rotate around the center of the screen. And so that case is just going to be 0, 0, 1. This rotates the model view matrix by the current value of square rotation around the z-axis. So in this case, the z-axis is the depth, the foreground background axis. Okay, so we're going to need to add some code that changes the value of square rotation over time. So essentially, we're gonna track the time from which we last drew the square, and kind of just render it, slowly in a circle. Okay, so we're going to add the following code at the end of our main function. So we'll go back up to main, which ends here. So after we call draw scene, we're going to say let, and I'm changing the syntax from var to let because we have newer, better syntax now. So I'm going to say function. Oh, let's see, following code to the end of the main function. Just double checking where I need to put this. Yeah, so it is inside of main, all right? Not function. Function render now. And we're going to do now. Convert now into seconds. I love this next one. Const delta time equals now minus then. Now and then. And then equals now. So now we're modifying. So it looks like we're doing some time travel here, but. And after that, we're going to draw our scene. And let's see. So instead of these, so actually what I'm going to do is I'm going to remove, so we have draw scene up here. I'm going to take it out of here. And I'm going to put it inside of our render. They don't tell you really, they don't really tell you to do that either. But we need to take it out from, it's not standalone anymore. Now it's a part of our render function. All right, so draw scene. Request animation frame, render. And then we need another render outside of the function. Frame. Okay. Let's see what that did. All right, so this code uses request animation frame to ask the browser to call the function render on each frame. So it's just redrawing it over and over again. And it passes us the time in milliseconds since the page loaded. We convert that into seconds and subtract it from the last time to compute the delta time. So the time difference, which is the number of seconds since the last frame was rendered. At the end of the draw scene, we add the code to update square rotation. Okay, so the last thing is square rotation plus equal delta time. Okay, so let's see, where does delta time get used? At the end of draw scene. Okay, so we need to go down to draw scene and add this little code snippet. Where is draw scene? To find it. Okay, draw scene. And so essentially we're timing our rotations of our square. Assuming this goes at the end. Yeah, at the very end, I'm going to add this little snippet that's going to help us do our rotation. Our rotation plus equal delta time. Okay. This code uses the amount of time that's passed since the last time we updated the value of square rotation to determine how far to rotate the square. Yeah, so I think that's kind of interesting. It's using time, the time since it's using time to compute how far to rotate the square at any given point. So that's kind of interesting. All right, let's see if it spins. No spinning yet. Did I save? I did save. That's fine. Okay, let's see if we got any errors. Yes, we have an error. Okay, good. Gives us something to look. Okay, square rotation delta time. Delta time is not defined. Okay. Okay, so it doesn't like it being there at the end of our function. Okay, that's fine. I wonder if there's another declaration. So it does need to be inside of draw scene. Scope, gotta love it. It told us to set delta time inside of the render function. Interesting. Okay. How does that work? Okay, that's fine. Let's look at sample 4 code and just see what we need to do. So we've got our render, right? They declared delta time there, which we did. And we render it. And then down here in draw scene. Square rotation there. Okay. Delta time isn't in scope. Oh, it needs to be passed in. Aha! Ha ha ha. Yes. We need to pass it in to draw scene as a parameter. They didn't tell us that either, did they? But in order for it to work inside of this draw scene function, we needed to pass it in as an actual parameter so that we could use it later. Yeah. All right. Try it again. No more errors. Okay. Cube is gone. So now we have invisible cube, but no more errors. So that's a start. Okay. We didn't have any errors, right? Yeah. Okay, good. Well, not good because it doesn't tell us what we did wrong, but all right. So we've got delta time. Got our square rotation. Checking that. Okay, so it must be a problem with the actual delta time, the actual time function. Okay, the rendering. So let's look at that. All right, so we've got init buffers, then render. Now delta time, now minus then. Ah, there it is. All right, and I'm not passing it in to draw scene here either. So delta time needs to be passed in. There we go. Okay, it was missing a parameter. Okay, so delta time needs to be passed in to draw scene, otherwise it's not going to render at all. Render properly at all anyway, because it's missing a parameter. It's expecting a parameter and not getting it. So, okay, try again. Hey, spin cube. Or sorry, spin square. Not a cube yet. Sometimes you just want to watch a square spin. So I'm already thinking, wouldn't it be fun, like, you could put this on like your portfolio, right? You could have something, you could put, instead of colors, you could put like a picture or your logo or something like that, and actually like have spinny square in your portfolio, just like spinning away. Or you could put it, like on your GitHub or something, just to be eye-catching. That would be really fun. Have spinny square on your portfolio and really catch some eyes. Or a transparent image of a clock hand. Yeah, that would be cool too. Like a spinning clock hand. Yeah. That would be cool. Whatever you want to spin. Leon's face or what have you. What browser do I use? I'm using Chrome. Yeah, this is just Chrome. All this is happening. This is happening in Chrome. There's nothing special about it. We didn't have to install anything. That's what I think is pretty neat. Is just with a little JavaScript and a little WebGL, we can make spinny square and then later spinny cube. We're gonna make spinny cube next. We're gonna make this 3D. The very next thing we're gonna do. So we've got spinny square going, and next up is spinny cube. But still, I really think this would be like super, having these sorts of things somewhere, on your portfolio or wherever they are, would be really great for like, advertising yourself. Even if you don't know how to do this stuff, like you still did it, right? You still wrote the code. So that counts. Absolutely. Developer, like I think a lot of people underestimate how much of being a developer is like just having a bunch of snippets on hand and just being able to just like, Control C, Control V to where you need them. So It's more about knowing where to put them than it is about exactly knowing literally everything about how they work, at least in my experience. Okay. Last thing is turning from spinny square to spinny cube. 100 hours snippet API. Yeah, code snippet API. There you go. There you go. All right, so last one we're going to do is creating 3D objects using Webgl. And we're going to take our square into the third dimension by adding more faces to create a cube, okay? So we're going to turn our array of vertices into a table and define the positions of each face's vertices by calling draw elements. So each face requires 4 vertices to define it, because basically what they're saying is a square has 4 corners, right? Yes, a square has 4 corners. Beep, boop, boop. But each vertex is shared by 3 faces, because if you think about the edge, the corner of a cube, right? If you look straight at the corner of a cube, it's actually a pyramid, right? So, and a pyramid has 3 faces. That's triangle, like this. A pyramid has, if you look at a pyramid from the top, it has 3 faces, right? So we can pass a lot fewer data around by building an array of all 24 vertices, then referring to each vertex by its index into that array instead of moving entire sets of coordinates around. Okay, so each corner belongs to 3 faces of different colors, and a single vertex needs to have a single specific color. This sounds like a Code Wars problem. We will create 3 copies of each vertex in 3 different colors, 1 for each face. Okay, don't worry about that too much. We're just going to redefine our positions a little bit. Okay. So we're going to take our positions inside of our init buffers. So let's see, inside of our init buffer function, which is right here. Originally, we just had this fairly small set of positions, which was basically helping us define each corner of our square. And we're going to turn that into a full cube. So essentially, we're going to take this and we're going to take it from one face into 1, 2, 3, 4, 5, 6 faces. Yeah. And speaking of APIs, what is everybody doing their API on? I'm just curious because somebody asked me they were struggling to come up with an idea for their API, and I'm just like, well, I mean, think about something that you like, right? Like I'm doing a Star Trek API because I love Star Trek and I know way too much about it. And I need to put that knowledge somewhere. But what's everybody doing their APIs on? And I'm just going to copy and paste this, by the way. There's no way I'm typing this out. So we're just going to replace our positions, right, with basically this is just each face of the cube. X metrics, you don't got to be in 100 devs to build your own API. Come on. Or if you want to build an API, you can basically just watch either my previous streams where we kind of do that, or check out Leon on YouTube, who we're following, and you can learn how to build one if you don't know already. Maybe you do, but oh, your group made an API for coding resources. Oh, that's fun. Anybody else? What else did y'all do? Okay, so we've set up the positions of the faces of our cube. X metrics, yeah, I'm not doubting your abilities at all. I don't know, I don't know what you know and what you don't. So, but yeah, it's fun. I'm enjoying it, building an API so far. Oh yeah, Rascal, you're doing the TV quotes API. You search for text and return the season, episode, and timestamp. The quote was, that's awesome. Yeah, I need to check that out, Rascal. You can tell because I have 0 friends. It's all about time, right? Like what time do you have and to do, and you just choose how to spend that time, right? Maybe it's with friends, maybe it's coding, learning things, who knows? Maybe it's playing video games. None of those things are necessarily bad ways to spend time, just different ways. We only have so many hours in the day, right? Okay, so we've added all of our faces. So we've added a Z component to our vertices because we're 3D now. We need to update the num components of our vertex position attribute to 3. Okay, so we talked about positions. Let's see, where's our vertex attribute pointer? Okay, so right down here we originally had number of components being 2. So we just need to update this to 3. And then we also need to, let's see, double check this. Program info, num components, type, normalize, stride, offset. Okay. Enable vertex array, program info, vertex position. Okay, that looks fine. You started one for guitars. Oh, that's a fun. But got bored and did a simple one for original launch Overwatch characters. Okay, yeah, that's cool. I feel like video games and movies and that kind of thing. They're really great API subjects, right? Because a lot of the data is interesting, but also very quantifiable, right? You've got character names, you've got power sets, you've got actors, if or whatever, and yeah, I think a lot of that is really nicely quantifiable, so good for an API. Okay, we set our components, and the next thing we need to do is just set our colors. So we need an array of colors for our vertices. Okay, so this code defines a color for each face, then uses a loop to assemble an array of the colors for each of the vertices. Okay, so let's see where this needs to go. This needs to go below our buffer data, it looks like. Oh, you did a Doctor Who API? That's awesome, Instinctive. I love Doctor Who, by the way. I haven't really talked about it on stream. I mostly talked about Star Trek. But I do really, really love Doctor Who. Okay, so originally we declared our colors. I scrolled all the way down there, but originally we declared our colors just below where we declare all the faces. So we have const colors. This was our original color set, but we're going to be adding to this now to essentially set up the colors for all of the faces. Yeah. And yeah, Doctor Who is a great thing to do an API on. Because again, yeah, very quantifiable, lots of data there. So Max, I did an animal flatulence app. Not fit. Okay, hang on. I'm gonna need some more details, Max. Yeah. What? Tell me more. You can't just set that out there and then drop the mic and walk away. I'm sorry. What is that? Okay, so I'm gonna replace colors with face colors. So it's just gonna have some more information in it. I'm gonna have that back a little bit. Whoop. Sorry. There. Okay, well, we're gonna check that out in a minute. I'm gonna finish doing this. We're gonna make cube spinny, and then we're gonna have to check that out because that is a truly creative idea, I must say. Okay, so we've got our face colors set up here, and prior to our color buffer, we're gonna need a little bit more. So we're gonna say let colors, and we're gonna put our colors into an empty array, and we're gonna loop through that array for let j equals 0, where j is less than face colors dot length plus plus j. It's interesting they're doing j plus plus j here instead of j plus plus. Interesting. And oh, I forgot my semicolons. Gosh, man. All right, semicolons do matter in that context. All right, const c face colors j. Okay. And we're just sort of reassembling this array. Colors concat with the same color for each of the 4 vertices of the face, right? So because colors render outward from the vertices of the face, so for each square face, we want it to be a solid color. So we have to set the color for each corner of each square. Basically, a does it fart API. Oh, I love it. That's great. All right, so we've got our colors set up, our color array. I'm curious as to what this looks like right now. Okay, so nothing right now because we're in the middle of, we're still in the middle of it. But I shouldn't be, I gotta be patient. Okay. Once the vertex arrays are generated, we need to build the element array. Okay, now let's see, where are we? Context, index buffer. Okay, so we're just gonna keep going in this. So below our color buffer, prior to the return, we're gonna add a little bit more code. So const index buffer, create buffer. And so this is, so I talked earlier, a little bit earlier about like noticing patterns, right? I don't know what's going on, but I am seeing patterns in things, right? So we start out, we declare like a buffer of some kind, right? And then the next thing we do is we bind it to the context. And so I'm seeing these repeated patterns, and I'm starting to get a little bit of a feel for the types of things that we would do. I mean, it's not like I could do this from scratch by any means, but this is how you start to learn a new topic, or at least how I start to learn a new topic, is I just do it, and I start to notice commonalities as I go. So we're creating an index, we're binding it, right? And then the next thing, so judging from what we've done before, we created our index, we're going to bind it, and then I think at some point we're also going to have to set some buffer data, okay? However, in this case, we're not going to do it right away. We're going to set our indices for the positions of this information. So indices, I'm gonna have one more array here. Whoops. And I get the question a lot from folks basically saying, how do I get started on projects? Or you know, I don't know how to do a project. And the thing is that you just need to pick something that sounds interesting and do it, right? Like, just, you know, it just doesn't matter if you know how to do it. Just pick something and do it. And I think that's the hard part for a lot of folks with like the 100 hours projects, is like, I don't know what to do, or, oh, I don't think I could do that, or, you know, something like that. And it's like, well, just start doing it, see what you can get. And then if you want, and then in the process of doing, you'll think of more things that you want to do, and you'll learn how to do those things. So, you know, that's the reason why I like to just jump into stuff like this, is just because this helps you think, ooh, something, you know, I want to make a spinny square, or I could use a spinny square in my portfolio. And then that helps you learn more about the concepts behind it. All right. So, and like I said, like I said before, I suspected that, you know, we create a buffer, we bind a buffer, and we set buffer data. So we did the create, we did the bind, and now after creating the index, where we are going to go ahead and do the buffer data. So that's a pattern. New uint 16 array. We're going to do indices. Put indices into that array, and we're gonna do our static draw. Oops. Okay. And then we return that. We need to return all 3. We have position, color, and indices. Buffer. Oops. All right. So the indices array defines each face like a pair of triangles, specifying each triangle's vertices as an index into the cube's vertex arrays. Thus, the cube is described as a collection of 12 triangles. Okay, so like dividing each square face into 2 triangles. And yeah, there's tons of devs. That's the thing that I love so much about working in tech, is that there's such a big helpful community out there. I mean, the internet is generally a pretty hostile place, right? But in general, devs are really generally pretty eager to teach you about what they know, right? They want to share, and especially once you make it into the workplace, you're going to have a whole community of people. They're going to want to help you get on your feet and get started, because the sooner that you're competent, that's less work for them, right? The other devs are going to be like, oh, I can start offloading work on this person as soon as they're competent enough to help out, and so they're going to want to teach you. Yeah. um oh, Lava, you're making your own JavaScript game with Canvas. Oh, that's awesome. So Lava Dude, I'm actually not super great with Canvas. I'm learning it. um but I wonder what issue are you having. Somebody else in the chat here might be able to help you out. It feels like typing out code 100 years from now is going to be the equivalent of coding with punch cards almost 100 years ago. Off topic, but funny to think about. Yeah, I mean, I don't entirely disagree, Fat Cat. There's certain tools now. What's that? GitHub Copilot, right? That can actually kind of write code for you to a degree. And you have things like, machine learning to various degrees that can, basically program itself. And the humans don't really know exactly what's going on under the hood. And so, that sort of thing is just beginning, right? I think we're just on the cusp of sort of self-generating code. We still have to do a lot of things manually for now, but I think there's going to be a point where a lot of things just happen automatically and we don't necessarily understand what might be happening, line by line. So I think that's really interesting to think about. Oh yeah, Rascal, that's a good point. Tiny Chicken Code Squad on Twitch, they're making a Canvas game called Dwarf, I think. Yeah, and it's like a, you know, sort of a pixel art kind of game. Um, yeah. Yeah, see, there's a lot of folks in here that are using Canvas or know someone who is using Canvas. Okay, so the last thing we're going to do is we're actually going to draw our cube. So we set up all the components, and we're going to need to add code to draw scene. So we're adding a couple different new calls. Okay. Let's see now, where does this go? So we need GL bind buffer. I'm guessing this is going to go at the start, but I'm not entirely sure. Draw scene, clear. Where do you go? Oh, it's actually going to go after our components. Okay, so we have our components 3 and 4. And after that, before used program, we're going to say gl dot bind buffer, gl element array buffer, and buffers dot indices. Okay. Got our matrix counts. And the last thing we're going to do is so below our matrix counts here, we have this object where we're doing some drawing. And we're doing like triangle strip and that sort of thing. We're going to modify this a little bit. So I'm just going to kind of redo this. So we're going to say const vertex count equals 36. Const type equals gl dot unsigned short. Const offset equals 0. GL draw elements And we're going to be drawing some triangles because remember we set up our square faces as triangles previously. Count, type, offset. Okay, we'll save that. And since each face of our cube is comprised of 2 triangles, like we said before, there are 6 vertices per side, or 36 total vertices in the cube. Okay. And the final thing we're going to do is we're going to replace our variable square rotation with cube rotation. And we're going to want to add a second rotation. So previously it was just spinning like this way. We're going to want to add that tumble as well, the tumble spin. So cube rotation, okay? And so inside of our mat for rotate, so I think that's going to be up top. So we're saying cube rotation here, and then up top in our rotate function, I think we're going to want to change that as well. Maybe not. Hang on, where is it? I'll find it. Find that mat for rotate. Here. Okay, so in mat for rotate, which is inside of our draw scene function, we just need to find mat for rotate and change it from, so we have model view matrix, cube rotation, and cube rotation times 0.7. I'm not sure what that's for, but fair enough. 0.7, and we're going to change that from 001 to 010. And okay, let's see what we get, if anything. Lava Dude, is that XML or HTML? So we are, well, we're writing in JavaScript right now. Yeah, we're writing in JavaScript right now, and then just using vanilla HTML for the rendering. So let's see what we get. Oh no, that's all right. Let's look and see if we got an error. Okay, we got an error. All right, great. That's going to help us troubleshoot. All right, C is not defined. Okay. All right, so can't see face colors. Okay, so I can see it doesn't like our face colors. Okay, that's fine. Look here. It doesn't want us to color our cube. Oh, that's right, because this needs to be inside of the for loop. So, doy. All right, that's a simple change. Because again, the scope isn't going to allow it to be outside of the for loop. It needs to be inside. So, where's my loop? All right, here we go. This needs to be inside of the for loop, like so. Okay. Now let's try it again and see if we get any other errors. Okay, all right. We got a little farther. Cube rotation is not defined. Okay. Cube rotation, yeah, all right. I was actually wondering about that because I didn't remember us defining it. So I imagine, let's see, model view matrix. So we set that here. But where do we set cube rotation? Cube rotation. Where do you? Oh, and I see too, I'm also missing a cube rotation as well. So we've got the translate. And again, they didn't tell us that this was not supposed to be a change, that this was supposed to be a duplicate. So we need 2 of these. Bad tutorial, bad. All right, map for rotate. This should be 001 still. You mess with the rendering of his WebGL stuff, it starts hurting your brain with highly. Yeah, yeah, it starts to look pretty wild, right? Yeah. Okay, so cube rotation. So we still need it to be rotating like this way, right? But we also want it to have the tumble effect. So doing both. Okay, there we go. Now, but where does cube? Okay. Bar cube. Okay. Ah, ha, 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 ha. I got it. All right. So cube rotation needs to be a global variable up here at the top because it needs to exist in multiple functions. There we go. Okay. Okay, so no error, but no cube. Where is cube? Okay, time challenge. I'm gonna see if I can solve this in the next 10 minutes. I think we can do it. Okay, so that's what it's supposed to look like, but we're not quite there. That's okay. To the GitHub. All right, we're gonna head to sample 5. We're at right now. And we're just gonna scan down here, see what might be missing. Seems like every time I troubleshoot, I get people, I can hear my little subscriber bell going off. So maybe I need to make more errors so that I can troubleshoot more often. Ah, strategy. Also, somebody play a hydrate. I'm really thirsty. Otherwise, I'm just going to have to, drink some tea of my own volition. And Lord knows we can't have that. Thanks, Rascal. Oh, thanks, Xmetric. Xmetric, wow, I should just stream then. I'd get all the subs, yeah. Nothing but troubleshooting gets you nothing but subs. Exactly. Okay, so we have this extra GL clear color thing here. That's not in their final GitHub, so I'm just going to comment that out for now. Doesn't seem to have caused any problems before, but okay. Model view matrix, project view matrix, void main void. Position, okay. Best source, fine. Info, color, form locations, const buffers, render. Render. Okay, that's fine. All right, init buffers. Create our buffers. Bind, yeah, okay, create and then bind, yep. Position buffers. I literally copied and pasted this array, so it should be fine. Const positions. For data, static draw, yep. Got our face colors. Our color array, we're looping through it, concatenating. Good deal. Create buffer, bind buffer, buffer data, static draw, index buffer. You know, somehow add another cube, more cubes. Double cube. Yeah, I probably could. Buffer. Okay. Array buffer. Array. Okay, got it. Return. Okay, returning all 3 of those. Color, depth test. Deal. Fit. Field of view. That should match. Eight. Translating here. We are rotating. And rotating again around the different axis. Vertex. So we got our components here. Okay. Right. We're binding our buffer. Matrix. False. Okay. Vertex count. Type, offset, draw elements. Oh, wait. Oh, man. I figured out the problem. I'm a dingus. Can anybody catch it? I'll give you a hint. It's in this object right here between the two brackets. Anybody spot it? Yeah, Andrea got it. Yes. Trianges. I can't spell triangles. Trianges. Yep. I got it. Yep. Triangles instead of trianges. That will probably cause that not to render properly because it doesn't know what a triangle is. Yes. So vertex count, type offset. I'm just going to double check the rest of these because we're almost done with the whole thing. So shader program. That was quick, Android. You got it. Android D, I'm sorry. Yeah. You got it. Okay. And the rest of these should be fine. We didn't make any changes now. So, all right, let's try it again. Cube! The whole thing didn't work because I forgot an L in triangles. Ain't that the way it goes, right? Successful cube. Go us. Look at it spin. So parody. Thanks, graphics. Yes. Thanks, graphics. Thanks, Andrea. Yay, cube. Our friend the cube. Technology. Yes. Champo, I would highly suggest since we just followed the tutorial here, I would highly suggest going here. I'll get you to the root of just go to the tutorial, go to the GitHub for the MDN tutorial rather than mine. So I'm dropping the link in chat for you there, Champo, or anybody else. Just go there. And what we did today was samples 1 through 5, right? So sample 5 is like the complete code. And then if you want to code along with each sample, then you can do them individually. And they kind of build on each other, right? So if you want to go farther and like add textures or lighting effects, you can do the rest of the samples as well, 6, 7, and 8. But this timed pretty well, I think, actually. 3 hours is about how long I want to go. And so that was pretty much perfect. But yes, our friend the cube is spinning again. Now we have 2 cubes. Yes. My earlier version and the demo version. So we did good, I think. Yeah, thanks for hanging out with me tonight. This was a little different than my normal streams, right? Normally we have kind of a goal in mind and a class related project, but just really wanted to make a cube. We cube, indeed. Champo, did you set up, check your, Champo, check your HTML. Make sure that your HTML is correct. You may have an issue there with either not linking your script or not setting up your canvas. Because remember, you do need to have an actual canvas to put your stuff on. Sounds like maybe you don't have that. You need to have a canvas tag in your body in order for your stuff to render. New appreciation for spinning cubes. Yeah. I think the real challenge would be to try to make the actual like screensaver where the cube like morphs and flexes. I don't know. That might be a little bit beyond beyond our current skill level, but that would be really cool if you could make the one where, you know, it like squishes and turns into shapes and, you know, springs out like that. I'm glad you enjoyed it, Snarfin. I did this, to be honest, I did this mostly for me. You know, I didn't, normally I do my streams for y'all. This one was for me. Because I've literally had this tutorial like sitting in my favorites for like 2 months. And tonight I was just like, you know what? We're on a break. We making cubes. Yeah. Bad. Fail warning. Does it give you the line of code that's thrown in the air? Instinct Dev, does it give you the like? Can it? Well, if you look at it in the console, because if that's the alert error, you can just click OK and close that error, and then do your inspect on the console and see if you can figure out which line of code, kind of like how we talked about before. If you can figure out which line of code is throwing the error, you can maybe trace it back to where you maybe have a spelling error or something like that. Any other questions? Oh yeah. Hang on. Let's look at the fart API. I gotta know what this is about. Oh boy. Hang on, I'm full screening this. What even is this? All right. Thank you for reminding me of that, Andrea. All right. So random animal. Let's do bearded dragon. Okay. Good to know it farts. All right. Let's do a millipede. Oh, interesting. Oh, you even say what it consists of. That is really impressive. I dig it. And a scientific link, man. This is intensive. I am really digging this. Oh, thanks, Andrea. Unicorns. It's glitter and rainbows. Yes, of course it is. Oh, this is really good. Really good. Is there audio? I'm looking at my audio meter, my desktop audio meter, and I don't see anything coming through. I don't see anything coming through on the channel. And if there was audio, it would be playing on stream. Um, oh, okay. Maybe okay. Hang on. Let's see. I'm gonna look at my mixer here. I don't see anything triggering for me, but who knows? My speaker is up. Yeah, nothing's coming through for me, but I mean that doesn't mean it doesn't work. It's just maybe it's just not something about my settings. Yeah. Oh, no audio. Okay. Yeah. I was like, wait, am I crazy? Ah. All right. Best stream. Yes. I think this pretty much this capped off my day pretty well. It's been a weird day, and this pretty much makes that day. Yes. Oh, this is great. My friend's parakeet farted in my face when I was 9 years old. Oh. Your cube is messed up. How is it messed up, Xmetric? Oh, hydrate. Yep. I'm gonna finish my tea. Oh, I dig this. I'm gonna be looking at. I'm gonna spend some time, scrolling through this. Ah, that's a cool. That's cool. That looks really cool. It's a tesseract. Nice. I like it. It looks like a TIE fighter. I'm not gonna troubleshoot this right now, but I do think that's pretty cool what you did. Yeah, the vertices aren't connected, right? So there was one point where we connected the vertices, and I don't think that's happening here, but I think that's really cool. You guys are wizard. I know it was intentional. Yeah, I know it was intentional Xmetric, but I think it's cool what you did. Yeah. TIE fighter. Oh, a TIE fighter. Yeah. Okay, I get you. Yeah. TIE fighter cube mishap. Very cool. Very cool. Okay, let's find someone to raid. Before everybody drops off, let's make somebody's day and give them a little raid. So let me get this pulled up. Safety vest! Wow. Thank you so much, safety vest. Watch. I love it. So nice. All right, hang on. Get raid pulled up. Do it in a different. That window collapsing thing. Okay. Manager. Raid. And all right, what do you guys? Any suggestions? You want to? Hey, for those of you who are learning Canvas, let's read Tiny Chicken Code Squad, because I know they're using Canvas. So let's go ahead and raid them and see what they're doing. I don't know. They've been streaming for a while, so they might be wrapping up. I don't know how late they go, but let's give them a go, shall we? I think we did them last time too, but since we got some Canvas enthusiasts here. Um, yeah, we got Peter Boyer. Yeah, let's do Tiny Chicken just because some folks expressed interest in Canvas. So start the raid. That takes a couple seconds to get going. Hope you all had fun, and we'll be back to more of our regular type of programming on Sunday. But thanks for bearing with me tonight as we did something a little unusual just because I wanted to. But on Sunday, we'll go back to more regular projects. So I will see you again on Sunday, and have a great rest of your week.